In this video, we will talk about what consumer surplus is. And I want to begin with some background. So this is a topic in economics. So when a company prices an item, they are interested in knowing how much consumers, and there's a couple things that they're interested in. One, how much consumers are willing to pay, and what they actually pay. Because there can be a gap between those things. Some consumers may be willing to pay more than what the company is actually charging for that item. All right, so in economics, we typically write price, and I'm going to denote price as P, as a function of demand. And I'll denote demand by Q. That's the convention that we've used since Math 30. One way to remember that is that I think of Q as representing a quantity, and that's how I know that. It's a little bit weird that we don't call demand D. We call it Q, and the way I think about it is Q refers to quantity. All right, so notationally, what that would look like is I'm going to have P on one side of the equation, and I'm going to write P as some function of Q. So all the Q's are going to be on the other side. So I'm going to call that function D of Q. So for example, maybe the price would be something like 100 over Q plus 20 or something like that. That would be a function where I have P written as in terms of Q. All right, so I want to draw a graph of sort of a general demand function. Okay, so I'm going to draw some axes. So let's draw some axes. And in this convention, Q takes the role of X, and then P takes the role of Y. And then I'm going to draw a demand curve. So a demand curve may look something like this. They don't have to have exactly this shape, but typically they're going to be decreasing. And the reason for that is that a higher price. So as the price goes up, a higher price means less people will want to buy the item. So that means there's going to be a lower demand. So that's saying as the price goes up, we would expect the demand to go down. We would expect the demand to go down. And that is consistent with this general shape of the graph. Alrighty, so that means our graph is decreasing. This is a decreasing graph. So if you're noticing that back in Math 30, when we first talked about demand equations, we usually had Q by itself on the left and writing that in terms of P on the right. And that's true. For some weird reason, econ and math have opposite conventions. So we're going to be talking about that. We're going to be following the economics convention, where P is on the y-axis, Q is on the x-axis here. So next, what I'm going to do is let's pick a particular number of units. And I'm going to call that Q bar. So Q with a bar over it. Okay, and I'm going to mark that on the Q axis. So I'll put a tick mark and I'll call this Q. And wherever this is on the graph as a point, this corresponding price, I'm going to call that P bar. So in other words, if I take Q bar and I plug it into my demand equation, the output that I get, the price that I get, I'm calling it P bar. So for our purposes, Q bar is just some number of items, some number of units that are specified. So maybe this is something like 10 units, maybe it'll be 30 units. It'll be something that's specified by information given to us in a problem. All right, so that brings me to the first question I want to ask about this, which is, how much are consumers willing to spend on the first Q bar units? So we're going to call this quantity the consumer's willingness to spend on the first Q bar units. Okay, so this is something that I'm going to try to give kind of a conceptual explanation for what it ends up equaling. Okay, so there's some consumers who are willing to pay a really high price, like over here, for the item. There's some consumers, on the other hand, who would be willing to spend a lower value for the item, like over there. And there are other consumers who would be willing to spend somewhere in the middle. So overall, I need to consider this sort of total range of prices that they are willing to spend. Okay, and what would measure that is if I were to take the area under the curve, under this curve, until I reach Q bar. That would encapsulate all of these consumers' willingness to spend up to these first Q bar units. Okay, so what measures that area for us? Well, it's going to be an integral from 0 to Q bar of, and my function is called d of q, my demand function, and the variable here is q, so it's dq for my integral. And graphically, this is the shaded area above. This is the shaded area above. Okay, so this isn't a rigorous proof of why this is true, why it's the area. To make it more rigorous, they actually do this in our textbook, but we would need this. This can be shown with some Riemann sums. Alright, so I'm going to highlight this. This is one of our key equations from this section. So the consumer's willingness to spend is the area under this demand graph. Alright, so I'm going to now ask another question. How much do the consumers actually end up spending on these Q bar units? Okay, and this is called the consumer's expenditure, how much they actually will end up paying. Alrighty, so I'm going to draw the graph again, but maybe a smaller graph this time. Okay, so I'm going to draw some axes. So we have Q on this axis and P on this axis, and I'll draw a demand curve. So it's decreasing. Okay, and let's put Q bar somewhere here, and then where that point is on the curve, this corresponding price I'll call P bar. So how much do the consumers actually pay? Well, if the demand is Q bar, I know what the price of those items is. It's P bar. So their actual amount that they end up spending is just the price, P bar, times the quantity, which is Q bar, and that's their expenditure. In terms of the graph, when we multiply these two things, that is the area of the rectangle. It is the area of this rectangle. That's P bar times Q bar. And I can also think of that as an integral. This is going to be an integral from 0 to Q bar under what graph? Sorry, under what curve? It's under sort of this other curve. If I were to draw this curve where P bar is, and the equation of this curve is, normally I would write y equals whatever P bar is, but in this case I don't have y as a variable. I have P as the variable. So technically it would be P equals P bar. But so when I plug that into my formula, I'm taking the area under P bar, whatever that number is, and this is dq. Q is my variable here. Okay, so in this integral formula, this number, P bar, that price, is just some constant. All right, and let's highlight this as well. So this is our formula for consumer's expenditure. I can think about it as just being that price, P bar, times that quantity demanded, Q bar, or I can think of it in this integral form. All right, so we are ready to define what's called the consumer's surplus now. And the consumer's surplus is their willingness to spend minus how much they will actually spend, minus their expenditure. Okay, so what was their willingness to spend? That was the integral from 0 to q bar of the demand function d of q, and I got to write dq at the end. And then minus, what was the integral for consumer's expenditure? It was 0 to q bar. And then inside of it, I had p bar, whatever that number is, dq. And the nice part about writing integrals for both of these is I can combine these into one. This is the integral from 0 to q bar of d of q minus p bar. P bar is just a number. And then I write that dq at the end. And this is called the consumer's surplus. Okay, so I'm going to highlight this as well. That is the big idea for this section, what consumer's surplus is. So in terms of the graph, so if I go back to this graph, what we're doing is we're subtracting the willingness to spend, which is this whole area under the demand curve, by the area of this rectangle. So by the area of this rectangle. And what that will leave us with is this region above that rectangle, but below the curve. And that is CS. That is the consumer surplus. So I'm going to shade that in a different color. So that is the consumer's surplus. And this rectangle area is the consumer's expenditure. So conceptually, the consumer surplus represents all of the extra money the consumers get to keep in their pockets because they may have been willing to spend more on the item than it actually cost. And that's indicated by this pink area here. It represents how much extra money they get to keep in their pockets above this price that the actual item ended up costing. Alrighty, so in the next video, we will do an example where we actually compute the consumer surplus.